In this video, I would like to present our approach to the data challenge in SIGIR eCom 2021. We tackled purchase intent prediction task and achieved third place in the leaderboard. We summarized our approach in a paper entitled Adversarial Validation to select validation data for evaluating performance in e-commerce purchase intent prediction. First of all, I would like to tell you the uniqueness of this challenge. The figure shows the final leaderboard and we ranked third position. And the score of the fourth position was given by a strong baseline, all their submission. This means that by submitting all samples as negative gave us a strong result, and it was too difficult to beat this baseline by using machine learning models. Before explaining our approach to beat the baseline, here is the overview of purchase intent prediction tasks. This is a dataset given by the organizer, and the dataset contains some events like searching, viewing, and adding to cart. And a sequence of the session was terminated at the event of adding to cart. And the task is to predict that the products will be purchased or not. And the interesting point is that the test data have some additional information after the adding to cart event. This is called NB, the number of browsing events, and NB is from 0 to 10. Of course, the bigger NB is, the more information we can use. This is a solution summary. We use two machine learning algorithms. The first one is the LightGBM, gradient boosting decision trees. And the second one is the neural networks, transformers and LSTM. And in both algorithms, we created 6 models according to the values of NB. This is because we believed that every NB has a different information. And this is a final pipeline. For NB from 0 to 8, we just predict all samples as negative. And for NB equals 10, we used the machine learning model's output and predicting a few samples with high confidence as positive by rank averaging of 2 models. This is a final pipeline, and it works to outperform the baseline. I would like to emphasize some key points of this challenge. There are several difficulties of this challenge. For example, train and test data were split by timeline, and participants had to extract train data from the original data. This may be the risk of future engineering mistakes. And there was an extreme class imbalance. And finally, only 10 submissions were allowed for the final stage. Therefore, we believe that validation methodology is very important in this challenge. And in our understanding, simple cross-validation wouldn't be appropriate due to the problem of concept drift and class imbalance. This is a simple explanation of cross-validation and adversarial validation. Cross-validation is a common way to evaluate machine learning models. The data is divided into k holes, and k-1 holes are used for training, and the other hold is used for validation, which is done for all combinations. On the other hand, adversarial validation is a little tricky way. A binary classifier is trained to predict whether a sample belongs to test data or not, and training data, which is highly similar to test data, is sampled for validation data. This approach tackled the concept drift problem. This is our validation strategy. The first step is cross-validation. We train all the models, and we can get all prediction values of the training data. Next step is adversarial validation. We can select validation data from all trained data, and we can calculate the validation score based on the selected data. This is the validation result. As you can see from the table, that adversarial validation result told us that the bigger NB model performed better. And actually, using NB equals 10 model led us to outperform the baseline, as I explained before. The other models didn't work for us. When we use all validation data and random selection data, we couldn't get any insight, which can be used for submission. This is the conclusion. This paper described the methodology of using adversarial validation to select validation data for the evaluation of machine learning models. We tackled the eCommerce purchase intent prediction task, and the insight gained by the proposed methodology enabled us to outperform the baseline. Source codes are available at this GitHub link, and this is the paper information. Thank you for your attention.